f of x is equal to x minus 1 times x minus 2 times x plus 1. Part A states the coordinates of the point at which the graph y equals f of x intersects the y-axis. So it intersects the y-axis when the x-coordinate is 0. So if I substitute 0 into the function, so I'll put 0 here, I'll put a 0 here, and I'll put a 0 there. So the 0 minus 1 is minus 1. The 0 minus 2 is minus 2. And the 0 plus 1 is 1. Multiplying those together, we get 2. So it's going to intersect the y-axis at the coordinate 0, 2. And that's my answer for part A. The rest of this question is about graph transformations. So I'm actually going to draw out the f of x graph so I can it'll help me to explain this question, parts B and C, a little bit easier. So, set of axes. Okay, so we've just seen that f of x intersects on the y-axis at the coordinate 0, 2. Here. Looking at where it intersects on the x-axis now, it's going to intersect when x equals 1, or when x equals 2, or when x is minus 1. So my f of x graph is going to look something like this. Right, that's my f of x graph. Let's have a look at part B. The graph of y equals a f of x intersects the y-axis at the coordinate 0, minus 4. Find the value of a. So this a at the front here, it's outside the function. It affects the y-coordinates. And it's a times f of x, so I am multiplying my y-coordinates by a. And it is now intersecting the y-axis at the coordinates 0, minus 4. So previously, the y-coordinate of the intersect was 2. It has now become minus 4. So what have we multiplied by? We've multiplied by minus 2. 2 times minus 2 gives me the minus 4. So therefore I can say that a would have to be equal to minus 2. Then let's have a look at part C. We're told the graph of f of x plus b passes through the origin. We need to find 3 possible values of b. Now the plus b on the inside there, that affects the x coordinates, and I do the opposite. So for example, if b was 5, x plus 5, if I did y equals f of x plus 5, that would move the x coordinates. I would subtract 5 from all of them, so that would translate the graph 5 squares in the negative direction. Remember, when the constant is on the inside of the brackets, you always do the opposite. So we are translating the graph in the x direction. And it ends up passing through the origin. So what could the possible values of b be? So let me just draw out the original function. So where b is 0 here. So where I'm drawing this little red line here is this. It's as if b was 0, so I've not translated it at all. Right, so we can see that I can now, if for example I made b 5, like I said before, it would now go 1, 2, 3, 4, 5 over there somewhere if b was 5. So how could this end up being going through the origin? Well, it could move 1 square to be there. Hopefully you can see that has been moved 1 unit from there to there. It was originally going through the point 1 here, it is now going through the origin there, so it has moved 1 unit in the negative direction. So that corresponds to b being 1. If it moves 1 square in the negative direction, then that is like me saying y equals f of x plus 1. So b would be 1 in that instance. That's one possible answer to make this graph go through the origin. It's not the only one. It could also have gone like this, where the point where it was intersecting at 2 here, now it's moved 2 units, 1, 2, and passing through the origin here like this. So in that case, it would be that b is 2. The final option would be that actually, if it had moved the other direction, if it had moved 1 unit in the positive direction. So that would be if b was minus 1. If we had y equals f of x minus 1, that would be saying to move 1 square in the positive x direction, because again, we always do the opposite. X minus 1 on the inside there means we're going to add 1 to all of the x coordinates. So these are the 3 possible values of what b could have been, so that f of x plus b passes through the origin.